Hi everyone, this is Vijayalakshmi Sugnali from WinMaths. Today I am going to discuss the problems on relations and functions exercise 1.1. In this session, we have discussed the problems. We already discussed last session from 1 to from first main all questions we have done. In that questions, second one, show that the relation R in a set of real numbers defined as R is equals to A comma B such that A is less than or is equals to B square is neither reflexive nor symmetric nor transitive. In this question, they given relation, that is R is equals to A comma B such that the pair of elements A and B are A is less than or is equals to B square. Here one condition is satisfied, or for example less than condition will be satisfied or equal condition will be satisfied for pair of elements A comma B. In that question we have to show neither reflexive nor symmetric nor transitive. It means the function is not reflexive, symmetric as well as transitive. Okay, then we consider some examples. Here mainly the relation R in the set of real numbers. Real numbers means all the numbers including, all the numbers including, that is the real numbers contains rational numbers, integers, natural numbers, whole number, odd number, even numbers, and at all. Okay, here for every value, whatever the numbers we have taken, for every value the relation must be obeys. Okay, here taking one example, if the relation is reflexive, first condition, that is reflexive condition. Consider an element A. Consider an element A that is A comma A belongs to R. That is A is less than or is equals to A square. Let me check for the condition. Okay. For examples, we have taken one example 1 comma 1. Here put A is equals to 1 and A square is also 1. 1 is less than or is equals to 1. Here 1 is equals to 1. The condition will be satisfied. But our conditions say neither reflexive. Then check for another condition. 2 comma 2. Here put A is equals to 2. Then the value becomes 2. Then A square will be 2 square. That is 2 is less than or is equals to 4. That is 2 square is 4. This function is also obey for this condition. Then obey while taking 1 by 2 comma 1 by 2 such that 1 by 2 is less than 4. That is 1 by 2 is that 1 by 2 square. 1 by 2 square, that is 1 by 2 is less than or equals to 1 by 2 means 1 square will be 1 and 2 square will be 4. Here check the condition. 1 by 2 value becomes 0.5. 1 by 4 value becomes 0.25. Which one is smaller? 1 by 4 will be smaller. Hence the condition not satisfied. Therefore A comma A not belongs to R. It is not reflexive. Again, for symmetric condition. taking an example is very important here. Okay, next, for checking the value, we have taken any two real number, 2 comma 5. Okay, 2 comma 5 belongs to R. Checking the condition, A value becomes 2 and B value becomes 5 square. 2 is less than 5 square, that is 2 is less than or is equals to 25. The condition will be satisfied. Again, that implies 5 comma 2 belongs to R. A value becomes 2, less than or is equals to 2 square. 2 square becomes 4. 5 is less than or is equals to 4. Here 5 is greater than the 4. Hence this condition is not satisfied. Therefore, it is not symmetric. Again, for checking third condition, transitive. Okay, we check for the condition transitive. Here, while taking an example, that is 2, minus 2 and minus 1. Here first consider 2 comma 2, that is minus 2. Here first A condition, A becomes 2, less than or is equals to minus 2 square. That is 2 is less than or is equals to 4. The condition satisfies. And consider minus 2 and minus 1, which is belongs to R. That implies minus 2 is less than or is equals to, this one is taking as A, then this number will be taking as B, minus 1 square. That is minus 2 is less than or is equals to 1. Minus 1 square will be 1. Okay, this one is condition becomes satisfied because minus 2 is lesser than 1. That implies, now taking 2 and minus 1. 2 and minus 1 belongs to R. Here A value becomes 2, less than or is equals to minus 1 square. Hence 2 is less than or is equals to minus 1 square become 1. 2 value becomes larger than the 1. Hence the condition not satisfied. Therefore, it is not transitive. Hence, therefore, it is shown or proved. Because in the question they asked, show that the relation R in a set of real numbers defined as a relation R is neither reflexive nor symmetric and nor transitive. Hence the proof. Now, again, taking another question, question number 3. Okay, this one is also similar to that kind of questions. Okay, that is check whether the relation are defined in the set 1 2 3 4 5 6 as R is equals to A comma B such that B is equals to A plus 1 is reflexive, symmetric or transitive. They have given in question, check. Okay, it may be possible or not. First condition, here A is equals to a set 1 2 3 4 5 6. Then the relation R is equals to A comma B such that B becomes A plus 1. Now write the relation. R is equals to A value becomes 1, then B value 2. Okay. Again, for A is 2, it is 3 up to 6. We have to write up to 6. But here the relation are defined on the set. So B value, A and B value must be 1, 2, 3, 4, 5, 6. Okay. Then for A value 3, B becomes 4, 4, 5 and 5, 6. Because A has 6 but B doesn't have 7 in this set. This is the relation. Check for reflexive condition. Okay. For this condition, here 1, 1 not belongs to R. Again 2, 2 not belongs to R up to so on for 6, 6 not belongs to R. Therefore, R is not reflexive. These type of questions asked in 1 mark multiple choice questions. Okay. 1 marks multiple questions is also important for scoring. Next, symmetric condition. Here, for 1, 2 is belongs to the relation R. That implies 2, 1 is not belongs to R, because for symmetric condition 1, 2 belongs to R. That implies 2, 1 is also belongs to R. Hence it is symmetric. But here 2, 1 not belongs to R. In this relation 2, 1 is not there. Therefore, R is not symmetric. While taking next example or next condition, transitivity. Okay, for transitive condition, here 1, 2 belongs to R and 2, 3 belongs to R. That implies 1, 3 not belongs to R. Check. Here the relation 1, 2, 2, 3, 3, 4, 5, 5, 6. But 1, 3 not there. Therefore, R is not transitive. R is not transitive. Okay. Next one question. Question number 4. Question number 4. Show that the relation R in R defined as. This is also one of the important question for examination. Okay. Here check first. Here we have to consider the condition A is less than B. Okay. Show that the relation R already they given reflexive and transitive but not symmetric. Okay. Here also R is defined as for real numbers. Okay. Now checking the condition reflexive. For reflexive condition, here the relation is taken R is equals to A comma B such that A is less than or is equals to B. Here 1, 1 is belongs to R, 2, 2 belongs to R up to so on for any number, because the condition A comma B such that A is less than or is equals to B. Here A value becomes 1, then B value becomes 1. 1 is always equals to 1, 2 is always equals to 2, 3 is always equals to 3, while up to so on, which is belongs to R. It is reflexive. Okay, next again for second condition, symmetric. Okay, here for taking an example 1 comma 2. Okay, 1 comma 2 belongs to R. For condition taking 1 is equals to A and B is equals to 2. Okay, that is 1 is always less than 2. 1 is always less than or is equals to 2. That implies 2 comma 1 belongs to R. That implies 2 is less than or is equals to 1. 2 is always larger than the 1. Okay, hence the condition not satisfied. Therefore, it is not symmetric. Okay, again checking for third condition, transitive. Checking for third condition, transitive. Taking an example 1 comma 2 belongs to R such that 1 is always less than or is equals to 2. Again taking 2 comma 3 belongs to R, that implies 2 is always less than or is equals to 3. While implies by transitive condition we have taken first and third element, that is 1 comma 3 belongs to R, that is 1 is always less than or is equals to 3. Therefore, it is transitive. Hence R is reflexive and transitive but not symmetric. Now, next one question. Similar type of questions will be asked. Okay, these questions are little bit confusing but very important for examination. Here in this type of examples or questions, the main thing while taking an example is important. The main thing that taking an example is important. Here the question is quite different. Last two questions they are already given. It is reflexive, transitive or symmetric, or whether the function is not symmetric, neither symmetric nor transitive and not reflexive. But here check, it means we have to check. Okay, check whether the relation are in are defined by first taking reflexive condition. Okay, first we have to take the reflexive condition. Okay, let's consider the main examples or the main values of these questions. For example, while taking 1 comma 1, it is reflexive. For 2 comma 2, it is reflexive or not? No. Okay, it is not possible. Here taking, here R is equals to A comma B such that A is less than or is equals to B cube. For A comma A belongs to R, that is A is less than A square. Let me check. Okay, let us check while taking an example. Here for 1 comma 1. Okay, 1 a value taken will be 1 and b value becomes 1. 1 cube, that is 1 is less than 1 cube means 1. The condition satisfied. For taking 2, 2 is less than 2 cube. 2 is less than 2 cube. The condition will be satisfied. 2 is less than 2 cube means 2 will be multiplied by 3 times, that is 8. Okay. While taking an example, 1 by 2 is less than or is equals to 1 by 2 cube. Okay. 1 by 2. Then 1 cube will be 1 and 2 cube will be 8. The condition not satisfied because 1 by 2 is larger than the 1 by 8. Because 1 by 2 value becomes 0.5, 1 by 8 value becomes 0.88 something. Okay. Here, while let us checking, therefore a comma a not belongs to R. Hence, it is not reflexive. It is not reflexive. While checking second condition, symmetric. While checking the second condition, symmetric. Here, a comma b belongs to R, then b comma a is also belongs to R. Okay. If, for example, taking 2 comma 9. While taking an example 2 comma 9, for a value becomes 2 is less than or is equals to 9. Okay. 2 a comma b. Taking an example, a less than or is equals to 9 cube. 9 cube value becomes 2 is 9 cube. 9 will be multiplied by 3 times, that is 729. The condition will be obeys. But while taking 9 comma 2, a value becomes 9 less than or is equals to 2 cube value becomes 8. 9 is always greater than 8. The condition not satisfied. Therefore, it is not symmetric. Again, for transitive condition. Again, for transitive condition. Here, a comma b belongs to R and b comma c belongs to R. That implies a comma c belongs to R. While taking an example for example 1, 2 and 1, or otherwise taking 3, 3 by 2 and 4 by 3. Okay, 3, 3 by 2, 4 by 3. Because these values are given not transitive condition. Okay, because real numbers contain all the values. In the main intention for this example is showing not transitive condition, because a is not less than b cube. Okay. Now, for 3 comma 3 by 2, 3 is less than or is equals to 3 by 2 square. 3 by 2 cube. 3 square will be, 3 cube. 3 is less than or is equal to 3 cube means 3 multiplied by 3 times 27 and 2 cube means 8. These value, whole value becomes 3.375. Hence the condition satisfied. Again, for 3, 2 and 4, 3. That implies 3 by 2 less than or is equals to 4 by 3 cube. Okay. Here 3 by 2 value taken. 3 by 2 is always less than 4 cube means 4 is multiplied by 3. 4 4 is 16. 16 4 4 is 60. 16 4 is 64 divided by 3 cube. That is 3 3s are 9. 9 3s are 27. This value becomes 2.37. 3 by 2 means 1.5. Okay. This condition satisfied. But 3, 3 by 4 by 3, because first one is related to 3 not belongs to R. 3 value becomes 3. 4 by 3 value becomes 2 by 3 7. 2 by 3 7 is not equals to 3, which is lesser. Therefore, it is not transitive. The value becomes, remember, here the things that the question, wherever in the relation a comma b, a is less than b cube or b square, the relation does not reflexive, symmetric and transitive. Other than while taking a comma b, a is less than or is equals to b, then the function is reflexive, transitive, but not symmetric. Okay, it is should be remembered. Next one is smallest one and last question for this session. Show that the relation R in the set 1, 2, 3 given by relation 1, 2, 2, 1 is symmetric but neither reflexive nor transitive. While seeing an example, simply we say that A is equals to 1, 2, 3. Then the relation R is equals to 1, 2, 2, 1. Okay. Simply say that first condition reflexive. Okay. 1, 1 not belongs to R. Again 2, 2 not belongs to R. It is not reflexive. It is not reflexive. While seeing the question, we simply say the answer. Then symmetric. Okay. Here 1, 2 belongs to R and 2, 1 belongs to R. The condition satisfied. It is symmetric. Again for transitive. Here 1, 2 belongs to R. Again 2, 1 belongs to R. But first element is related to third element. 1, 1 not belongs to R. It is not transitive. Okay. It is not transitive. We show that. Therefore, R is symmetric but neither reflexive nor transitive. Hence the proof. Hence the proof. Thank you, dear students. Okay. End this session. Thank you.